Good morning and welcome to Honors Chemistry. Introductory notes. We're going to define chemistry. We're going to talk about observations and we'll talk a little bit about scientific notation. So we're going to define chemistry as the study of matter and its changes. So then we have to define matter. So matter is anything that takes up space. So that could be anything that is a solid, a liquid, a gas, anything that exists. What it's not, though, is energy. We have to define energy. Energy is not matter. Energy is the ability to do work. So matter is anything that occupies space. So anything you could think of, solid, liquid, gas, UI, anything in the universe. So we talk about what matter is and how it changes from one form to another. But the main idea we have to talk about is that matter cannot be created or destroyed. Which means that ancient chemists, what we call alchemy, their main goal was to change lead into gold. The basis of chemistry starts with this idea, but it cannot happen. We cannot directly turn lead into gold. We can react lead with other materials, we can react gold with other materials, but we cannot directly change lead into gold. But we can perform other reactions. We take hydrogen and oxygen gas in the atmosphere, we add a little electricity, we can make water. These are symbols. Hydrogen gas and oxygen gas. Water. Water is a liquid. This is plain old water. So this can happen. We also can take water and turn it back into its gases. We take water and add electricity going the other way. We can get hydrogen and oxygen gas. So these would be gases. This would be your liquid water. Now we can also have changes that aren't chemical changes. We call them physical. We'll talk more about that next unit. So I can take table salt, NaCl, and drop it into water and get the sodium and chlorine ions to break apart. So how do we know this is happening? And what we do is we take observations. So an observation is using senses and instruments to record what happens in nature. So we can have two main types of observations. We can have qualitative and quantitative. A qualitative observation uses your senses. And that could be smell, taste, sight, hear, touch. Now, one of the basic ones for qualitative, there's no numbers. So you could say it's cold outside, or it's hot outside, or something tastes sweet. So qualitative is those measurements and observations that are without numbers. Quantitative uses numbers. We can count, or you can use an instrument. Say we use a thermometer. We can say that it is 83 degrees Fahrenheit outside. We don't say hot or cold, we say that it's a temperature. It's a number. It's something you use an instrument. We can say that something is 14 inches long. Say we catch a fish out of the ocean. We also take its mass or its weight. We can say it is 3.75 pounds. Those are English units. We'll talk more about units in the next unit. So an example of that would be, if I have my two paintings here, qualitative would be that it is pretty, that it's blue. It's not a color picture, play with me. That it is a landscape. It's a type of painting. We can take quantitative data. We can talk about it is an 8 by 11 inch painting. There's also count. When you say there's one tree, one sun. So that's the difference. Another example would be, we just talk about just some generic stick figure person. So a qualitative observation would be that he is tall. A quantitative would be that he is 6 foot and 2 inches tall. You could say that he is thin. Or we could get a scale and weigh him and say he weighs 170 pounds. That is the basic difference between a qualitative and quantitative observation. We'll take both types in class and in lab. So the other thing I want to talk about briefly is scientific notation. Scientific notation allows large and small numbers to be understood. Before we get into this, let's talk a little bit about the why. Why do we have and use scientific notation? And the best idea I can think of to explain this is when we have a phone number without area code. I'll use my parents' home phone number back in West Virginia. It's 7 digits. The question is, why 7? There was a scientific study, and when they first started running telephone lines and coming up with telephone numbers, 7 digits seemed to be the maximum number that a person could remember in order at the time, on average. I mean, I still remember a lot of my other phone numbers from when I was younger, before the advent of cell phones. I guess they could make them longer now. The local pizza place I grew up in, my first girlfriend's number. Those types of numbers. If they were any longer, they're a little harder to remember. So scientific notation tries to take giant numbers and make them into something we can use. Usually the form for scientific notation is 1 through 9.9 as the front number. Then we write times 10, and n is the exponent. So say we have 1,000,000. We want to write this out in scientific notation. So I have to write the first number. And since it's just a 1, I'll write a 1. And I'll write times 10. And I count from where the decimal is until I get that number. 1, 2, 3, 4, 5, 6. So 1,000,000 is 1 times 10. Let me write that again. Times 10 to the 6th. If the number starts larger than 1, it's going to have a positive exponent. This tells me a larger number. Something that's smaller, so I have 0.002. So write in scientific notation, I place the 2, and I write times 10, and I move the decimal 3 times 3. But since the number starts less than 1, it's a negative 3. Let me rewrite it. So I have 2 times 10 to the negative third. If you look at your cell phone, and you look at the storage is 64 on general gigabytes. Well, that is this number written out. So to write this in scientific notation, we would write the number 6.4, and then we count how many spaces we move. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 64 gigabytes. So if you have another number, to write in scientific notation, I write the number, move the places. Since the number starts off smaller than 1, it moves it. And that's what these notes are saying. And the reason we use this in chemistry, one of the main numbers we use in chemistry is this number. And this number is 6.02 times 10 to the 23rd. We call this Avogadro's number. And really what it is the amount of things. It's an SI unit, the same as 12 is a dozen. So really, if you have 18 milliliters of water, just a little bit, that's what you have in molecules. Now, when we add and subtract scientific notation, we just use our calculators and place it in there. So adding, subtracting, multiplying, dividing, we'll do a couple examples using the example problems. But we're just going to use our calculator, scientific calculator, something like this that I've found online, or you can have your own. So we'll try a couple off the practice sheet, and then we'll let you work on some. So let's try this one. Place this number in scientific notation. So I need a 2.7 instead of 27. I write the other numbers and then times 10. I'm going to move this 1 decimal place. Now, the number is greater than 1 to begin with, so it's positive. So let's look at number 3. I write 4.9 times 10. I move it 1, 2, 3, 4, 5, 6 times. Now, when you have something in scientific notation already, what we're going to do is move it. How many places did I move? 1, 2, 3. It starts off bigger than 1, so I'm going to add 3 to that 20. So it ends up being times 10 to the 23rd. This one's already in scientific notation. Well, it's already in the correct decimal number, so it's a 3. So I write times 10. If I don't move the decimal, I place a 0. So we go and try this one. 2.7315 times 10, and I move it 2 places. The number starts off greater than 1, so this is a positive exponent. So if I try this one, and I move it 1, 2, 3, ends up being negative. So let's try and add and subtract and multiply. Now, 6.21 times 10 to the 5th is how it's said. How we put it in the calculator is this. And then we use the exponent. And then we're going to add that to 1.20 times 10 to the 5th. And then we hit equal. And you see it didn't change it. So we write down what we have. Oh no, I messed that one up. Let's see if I can go back and change it. Let's redo that one. Times 10 to the 5th plus 1.20 exponent fifth. So I get 74,000. That looks a lot better. 74,100 in the calculator. Now put that in scientific notation. 7.41 times 10. I move it 1, 2, 3, 4 times. When we multiply and divide, it's the same way. Say we try this one. 5.27 divided by 1.20 times 10 to the third gives me 1200, excuse me, and 5.27. So we'll put that in scientific notation. 1.20527 times 10 and exponent 1, 2, 3 times 10 to the third. So what you should be doing is trying some of these, say maybe 3 or 4 out of each section. Go ahead and give that a try. We'll go over it tomorrow, our office hours. I'll answer questions.